Hi, I am Rohit Bogula, and this is a demo of CrimeLens, an AI powered platform that transforms natural language crime descriptions into structured predictions, reasoning graphs, and explainable insights. The goal is to help investigators quickly understand crime scenes from noisy witness reports. So, this is the home page of the website. Uh, so, this is where you enter the crime scene input. So, I have provided three types of inputs: a natural language, a structured form, and a CSV upload. So let's try the natural language first. Let me just take one input saying John stabbed Maria with a knife at the apartment and fled. So let's pass the input. So the passing happens using the species NER extraction with rule based constraints along with domain encoders. So this helps extract John as suspect, Maria as victim, knife as object, location, and stabbed. So the crime type here is just a demi type. It's not the right one, so it's just a demi value. So let's try to predict the crime time through the model. So we can see this was a homicide. We have other kind of predictions as well. Like we generate a logit for each of them. So I'm just showing the logits that were generated from the model. So as we can see, the model is pretty confident that it was a homicide, and given the words like stabbing and knife and in the apartment, they all involve homicide itself. So now let's move ahead and let me just show a hypothesis generator. Here we can generate a report for the hypothesis that we initially predicted. Let me just show the graph view. So to show the graph view, I have trained a graph sage neural network that computes embeddings and predicts the crime type. So the generated graph is using network X and PyG visualizations. So we can see John stabbed Maria and John was at the apartment and uses a knife. So the legend shows for the persons and object and the location. So I also have a graph explainer which explains the predictions that we made and what contributed most to the prediction. So as we can see, there are a lot of entries and why, and we also have an explanation on why this graph makes sense. So this is how CrimeLens works. Let me show another input where I have a larger input in place. So these are like five uh, different events over the same uh, crime that happened. So let's pass. After passing, let us go to prediction and try to predict the crime type. So we can see that it was predicted assault as 91%, and there are homicide and kidnapping as well. So let me go ahead and generate a hypothesis. So we can see different hypotheses and the crime was changed. So going at the graph view, so the graph is now complex, and we can see how different objects contributed to the predictions. Like cash bag didn't have a lot of contribution to the prediction, but knife did. So yeah, this is the demo from CrimeLens. Thank you.